Good morning. I'm DavidMargolin, and this is another edition of the forecast contest where I'll kind of walk you through my process and provide you some thoughts. Um, so for today, I think I'm going to focus a little bit more on attribution. I will walk you through my forecast for today, but let's start with attribution just because I think the forecast that just verified, the most recent verification, was pretty interesting. So I'm going to go to 924 here, and that's our last verification. And as you can see, this is a forecast. This was our last actual CDD forecast. It was issued on 924, and it verified October 9th to October 13th, so just a couple days ago. Couple interesting points here. One, the forecast performance was not good by nearly all of the forecast inputs here, including myself. You can see negative scores indicate poor performance. Positive is good relative to the 30-year normal. I think there were potentially a couple of reasons for that in my high-level analysis here. One, the fact that the forecast verified very close to the 30-year normal. So here's the 30-year normal, 10.9 CDDs, and here's verification, 10.7. So this was a very good or accurate forecast from the 30-year. And so, obviously it's tough to beat. Another contributing factor to the poor performance, I think, was the fact that the spread, the sigma, for this forecast was actually quite low. And that's because it's late in the season. And so the sigma was only about 3 CDDs. And so any forecasts that were significantly different than that were going to suffer significantly. Another contributing factor potentially is, I'm speculating on these things, is the fact that this was also a significant pattern shift from what we've seen recently. For those folks who've kind of been following the forecast or the forecast contest, you know that for several weeks in a row now, we've had forecasts come in above expectations. In many cases, the verification has been above any of the inputs, and I think that's happened for about 4 weeks in a row. So I think this tends to be a human bias there in terms of kind of falling into that trap of, well, it keeps coming in warmer or hotter than expected, and that's going to continue. So that may have also been a contributing factor. All right, so those are just some thoughts there in terms of the numbers, but let's actually look back at the pattern and let's see what verified. So thanks to our friends here at Maxar, we have access to this great tool, Dynacast, and we can kind of look back historically at different levels, different times of the year, etc. So this is the verification window, October 9th to 13th, and this is the 500 millibar height anomaly pattern. And so you can get a look here, a good look at the pattern with the ridging up across the North Pacific, deep trough in the west, and then a bridge sort of NAO, negative NAO kind of look from Eastern Canada all the way out to Western Asia. All right, so we also have access to tools where we can look back at the forecasts from the 6, 10, 11 to 15-day period, verifying for that same window. So you can see here, and I'll show you just real quick where you can access this. If you're on this page where the composites, you can go to the archive, and I will give you a complete tutorial here, but then you can access some of the historical models, which is really an awesome feature. All right, so I'm going to go back to where I was. We're just going to look at a couple maps here for brevity. But this is I don't have the 16-20, otherwise I'd show that, but this is the 11-15 EC Ensemble 500 millibar, verifying for that approximately that same period, October 9th, 14th. And a couple of things strike me here, high level. One is that the 500 millibar pattern, not terrible. In fact, just to be more clear, I would actually say, again, this is subjectively speaking, I'm not running a pattern correlation analysis, but high level, I would say it looks good. It sees the North Pacific ridging. I'm just flipping back and forth here. It sees at least a weakness in the west, and it sees this bridge of higher than normal heights from Eastern Canada all the way to Asia. So it's not like I look at this thing and say, well, it's a 180, it completely missed the upper level pattern. All right, Next, I want to go to the 6 to 10 and see how that came forward in the 6 to 10. And again, I already have this kind of set up. And again, high level, similar type thing, and you would expect as you get closer, you would expect that the pattern to come into better resolution. But there is something that I do notice here, and I've seen this before. You see a little bit more high heights poking into Western Canada, which is usually a cold signal, because you can build more higher pressure and force cold south, etc. So that is one difference I saw there. It kind of looks minor, but it could be significant in the scheme of things. Now, I want to do one other thing here that I think is, relevant. I'm going to switch over to surface temperatures, right? Um, and we'll just zoom into the United States and we'll go back. And again, just for the sake of brevity here, we're just going to look at the EC Ensemble. Um, all right, here's the EC Ensemble. Here's what the forecast was. And let me switch back here, and I'm going to switch this to, well, I don't know if we have, oh, yeah, there we go. And let's look at let's look at how this verified. Go to the North America, and you could see we had a massive, pool of cold anomalies, basically just west of Chicago, and then all the way to the coast, and then the east was a little bit above normal, but kind of a little bit of a mixed bag. All right, and then here's our 11 to 15. Clearly, this is not capturing the spatial extent, and certainly not the intensity of the cold anomalies. All right, so that's the 11 to 15. Now let's go to the 6 to 10. Again, we'll have to switch this. So we'll go to the United States, we'll go to 2-meter temperatures, and we'll look at the 6 to 10 EC Ensemble. Now, I think this is pretty enlightening. So when we looked at the 500 millibar pattern, yeah, we saw some slight differences and not and potentially differences that could be material. But really, when you look at the difference here in the scope and intensity of temperatures, this is really, I think, where you see it in as the forecast came forward or evolved into the 6 to 10 day period. It really started to pick up the fact that this cold pull was much more severe than originally expected. And I think there's a lot more that we could look at with this forecast. I'm going to keep it focused on just kind of the topics we just talked about, and if there is a interesting or potential, I think, research takeaway here or something to further investigate. This could be a situation where I think you look at it, again, everything I'm saying is subjectively at this point, but from a pattern configuration standpoint, 11 to 15 days out, again, we didn't have a chance to look 16 to 20, but at least 11 to 15. The models may have captured the pattern, the jet stream pattern, as well as normally is expected, plus or minus. They might have done just had a average performance, may have even been slightly above average for just by looking at it. But clearly, it was the surface where the models missed it, and that does make me wonder, what happened there. And if we look back to where these forecasts were initialized, and we'd have to go back to kind of like late September, and I'll pick a date here, September 28th. And we look what was going on here. I think this could be potentially relevant. So even as these forecasts, were being issued, some in late September, there was a massive cold pool in Western Canada, and it's possible, I think, that the models underplay and underestimate and too quickly weaken these kinds of air masses. Um, uh, and that could have influenced that could have been at least a contributing factor as to why the models subsequently underestimated uh, the CDD or overestimated the CDD anomalies and underestimated the amount of cold that eventually did pour into the central and western United States. So I think it would be, again, final takeaway for folks that are involved in the forecast contest or otherwise. I think it would be interesting to do a study, historical study, maybe with reforecast study data, to look at situations initialized with lots of cold in Western Canada. Obviously, you have to better define lots of cold, and then look at forecast bias and error 11 to 15 and 16 to 20 days out and see if there is indeed a relationship there. So that's my 2 cents on with respect to attribution. Now we'll just do a quick dive into today's forecast process. Um, and I'm going to switch over to 1015. And Also, for those folks who are just really new to this, I usually skip this step just for the, again, to speed things up a little bit. But just before I do the video here, I enter my mean and sigma here, mean and sigma values. Formula statement is required there, i.e. 50% CFS, 50% EC. Strategy statement, I think, is really important because that talks about your process. Expected pattern configuration is optional. And then, of course, links to any research and data and code and things like that. So, in looking at today's forecast, the long story short of it is my formula continues to evolve. Like I think I've been talking about the last couple of weeks. I continue to kind of shift from my summer mode thinking to winter mode thinking, and mostly, and that's described here in my strategy statement. Mostly that means putting starting to put more weight on 30-year longer term normals as opposed to like 10-year normals. Again, based on my research and my forecast experience, which suggests that as we go into the winter, longer term information becomes more relevant. Climate change and whatnot is not having quite the same impact, at least as of yet, in the winter as the summer across the United States, and some ideas and theories into that, but maybe we'll get into that a different time. Finally, I just do want to mention that I did look at various MJO analytics, including Professor Roundy's, and there's also a great tool I want to give a shout out to, Caitlin's tool. You can see the link up here. It's an awesome MJO composite tool. The bottom line is I did not see a clear signal from the various MJO statistical historical information to skew away from my formula that you see here. Just the bottom line just wasn't a clear signal. Some of the data I thought suggest keeping the trough in the west. Other data like Professor Roundy's, more of a trough in the east. And then our MJO analog tool didn't really deviate too much from the 30-year normal. So anytime I get into a situation where I don't see a clear signal, I kind of steer away from that. There was a temptation. I'll just quickly go to the maps here. There was a temptation on my part, and I'm going to show here. I'll just show the EC weeklies. Here's the 1 to 5. This is 500 millibar pattern. 6 to 10, get a kind of a warm period in the east there. 11 to 15 and 16 to 20. I had a temptation here to maybe go colder than what my formula would suggest, based on some of the things we just talked about with attribution, that maybe the models could be underestimating the cold pool. That being said, the bottom line is I don't think some of the things we talked about is vetted out enough, or there's a distinct skew based on what we looked at yet. I just think it's an interesting research question. So I thought about maybe pushing it a little bit colder than what my number shows, but at the end of the day, I just didn't feel like I had enough to work with. So that's it for today. That's my forecast process, and we'll do it again next week. Thank you.